Hey everybody, welcome back to another SAT video. This is a question from the 2024 official Practice Bundle 6 Math Module 2. What is a positive solution to the given equation, right? So this is a pretty short, simple problem. I'll categorize it as easy if you understand how to solve um, polynomial equations, right? So that's kind of the key here. Easy with an asterisk only if you understand how to solve polynomial equations, right? So let's actually, before we begin, let's graph this out like kind of roughly, right? Figure out what this equation would actually look like. So notice we have three binomial terms. Binomial means a term with two elements, right? Two numbers. So we have three binomial terms, meaning that we would have an x cubed term if we were to expand this all out. Like if we were to multiply this all out into all its constituent terms and expand it, we would have one term with some coefficient a times x cubed, right? Which is fine, but that tells me that this graph, when we graph it on the xy plane, we are going to have uh, a shape that looks kind of like this, right? We're going to have some shape that like goes up and then goes down and then goes back up again, right? Because that's just how trinomial equations look like. Remember binomials look like that. That's when you have an x squared. So this is kind of like one step up. So when they are asking us what is a solution to the given equation, we should instantly think and look, right? We see this 0, right? It's equal to 0. So that should tell us they're basically asking for us at what points does this graph touch 0, right? Or when does it touch the x-axis, right? And if you notice, since there are three points, right? There are three solutions where this might touch the x-axis. Now, granted, I'm not basing this drawing off of this actual equation. I'm just kind of showing you the general format of such a equation such that you can kind of understand the underlying concept, right? So, like I said, we need to first identify that there are three x's, and then know that when you have some sort of polynomial set to 0, it simply means at what points does this graph or this line touch the x-axis. So with that concept being reviewed, now let's try and solve it, right? So they already did most of the work for us, right? They gave us these different binomial terms and set them all to 0. So now all we have to do is basically solve for x for each one of these binomial terms. We have x plus 2 is equal to 0. We would have x minus 5 is equal to 0. And we would have x plus 9 is equal to 0. Now, this might look very familiar if you have done Algebra 1 and went through your factoring or factoring chapters or polynomial, binomial chapters, right? Where you would, graph parabolas. This is probably looks like the last step, right? So they saved us the hassle of factoring and they just gave us straight to the last step. Now all we have to do is solve for x, right? So over here we will do minus 2, x is equal to minus 2. Then in this one, we just would do plus 5 on both sides. So this one would be x is equal to 5. And then the third solution would be minus 9 on both sides. So then x is going to equal minus 9, right? So we have minus 2, 5, and minus 9. Those are the points for this equation that touch the x-axis, right? Or the points where the equation is equal to 0, right? So we are being asked what is the positive solution. We only have one positive solution, right? And that is x equals 5. So our answer is going to be C. There you have it. Not a super complicated one. It was more of a conceptual problem. But if you just got to remember that whenever you have to solve for a polynomial equation and it is set equal to 0, all you got to do is just break up the binomial, set each binomial into its own little equation set to 0, and then solve for x that way. I hope this video was helpful for you. Let me know if there's any ways that I can improve this video. Always check out Khan Academy. They have a lot of good SAT prep and other subjects for self-study. And as always, thank you so much for watching, and I'll see you on the next one.